Hey there, in this video we're going to look at adding and subtracting rational expressions, which are fractions that may also include variables and polynomials in them. So before we can do anything with this subtraction symbol here, we need to create a common denominator. We want the bottoms of these fractions to match up. Well, how do we create that common denominator? To review, let's look at a simpler example first that just involves some numbers, and then we'll return to that problem. To create a common denominator of two fractions, what we can do is multiply something that is missing from one denominator into that denominator. So, for example, if I have 21 in the denominator here and I have 7 in the denominator here, what this denominator is missing is it's missing a factor of 3. If we multiply that 7 by 3, we can get that to turn into 21. So let's multiply 3 into the denominator of that fraction. But if we multiply something into the denominator of a fraction, we also need to multiply that same factor into the numerator so that the value of our fraction doesn't change. Because when we multiply by this 3 over 3, that's really the same as just multiplying by 1, so that doesn't change the value of this fraction. So let's do that and see what we're left with before we subtract. If we multiply 3 times 4 in the numerator, we get 12. And 3 times 7 in the denominator here gives us 21. And we're still subtracting that with 5 over 21. Now that we do have a common denominator, we want to combine the like terms in the numerators. So we're going to keep the denominators the same and combine these numerators into one fraction. 12 minus 5 gives us 7, so we have 7 all over 21. And whenever we're dealing with fractions, we want to check at the end of our problem if it's possible to simplify. Simplify means we can possibly divide by a common factor that goes into both the top and bottom of our fraction. And in this case, 7 and 21 share a common factor of 7, so I can divide the numerator and denominator by 7. Remember that if we do something to the numerator of a fraction, we need to do that same thing to the denominator so that our fraction stays balanced. So that leaves us with 1 in the numerator and 3 in the denominator. So to recap, what we did there is first we created common denominators of these fractions, and then after that we combined the numerators together, and finally we checked to see if it was possible to simplify our final answer. Let's return to this more complicated rational expression and see how we can subtract these. So we have 4a in the denominator on the left, which means we want to make this denominator on the right look like 4a. Well, the missing factor is a. If I multiply 4 times a, then that will turn into 4a. And that means I also need to multiply the numerator of this fraction times a. So we're keeping the fraction on the left the same because that already has the denominator that we want. And in the numerator of the right, when we multiply a times 5a, that becomes 5a squared because a times a is a. When we multiply a times negative 4b, b and a are different variables, so there's no way to combine them into a single variable. We'll just leave them both as variables in this term. 4ba means 4 times b times a. And that is all over 4a. Now that we have a common denominator, we want to combine together the terms in the numerators. And when we do this, we have to pay attention to what operation we're trying to do, if it's addition or subtraction. Since this is a subtraction problem, what we're really doing is we're going to subtract this numerator from the numerator we have on the left. And if we're subtracting a polynomial from something, that means that we need to distribute this negative sign to both of those terms before we combine like terms with the other side. So this 5a that we have, because there's a negative in front of it, that's going to turn that into a negative 5a squared. And our negative 4ba, that has a negative that needs to get distributed to that, and a negative times a negative becomes a positive. So that will turn into positive 4ba. So that is the numerator that we have on the left. And again, the reason that we switched the signs there was because of this subtraction symbol. If this was an addition problem, we would not need to change the positive and negative signs in that second fraction. We still have the same a plus 5b over 4a on our other fraction. So now I'm going to make a little bit more space for us here, and let's combine all of these like terms together. If two terms have the same variable and exponent, that means that they are like terms and they can be combined. So we've got negative 5a squared and positive a squared, which if we just see a squared by itself means that it is a 1a squared. So we can combine the coefficients there, and 1 minus 5 gives us negative 4. So we have negative 4a squared. 5b and 4ba are not like terms because they don't have the same set of variables. So we'll just leave those as two separate terms in our final answer. And all of this is over 4a. At this point, we would check and see if it's possible to simplify this fraction anymore by dividing by common factors, but in this case, there is no common factor that we can divide by, because although we do see a 4 in the denominator and we have a couple of 4s in the numerators, not every term in the numerator has a 4, because this middle term is not able to be divided by 4, so there is nothing we can divide by, and what we have in the box is our final answer. So here's one more example for us to try. We know that before we can subtract these two rational expressions, we need to make the denominators match. But there's actually something that we can do beforehand in this problem that might make our work a little bit easier. Whenever we're dealing with fractions, we can simplify a fraction by dividing by a common factor in the numerator and denominator. So I notice right off the bat here that we've got a common factor of 4 and 2 in the numerator and denominator of this fraction. So the fraction 4 over 2, well, that just simplifies to 2 over 1. So another way that I could write this expression on the right is 2 over 1x, or just 2 over x. And we can do something similar with this fraction on the right. That is the left. We can do something similar with this fraction on the left. We can divide the numerator and denominator by 2, and we can also divide the numerator and denominator by x because those share a common factor of x. 2x divided by 2x in the numerator is equal to 1. And 6x to the power of 3 divided by 2x in the denominator gives us 3x squared. So that makes our work a little bit easier when we're trying to create a common denominator, because now the expressions that we're dealing with in the bottom are simpler. So we want to look at both of our denominators and see if there are any factors that they are missing from each other. This 3x squared that we have in the denominator is already bigger than 1x. We don't need to do anything to 3x squared to add in any missing factors. The only thing that we need to adjust here is we need to make this 1x look like 3x squared. So there are a couple of factors that it's missing. We need to multiply by 3 so that we can get that 1 to turn into a 3. And we need to multiply by x so that we can get this x here to turn into x squared. If we multiply the denominator by 3x, that means we also need to multiply the numerator by 3x so that our fraction stays balanced. So we still have 1 over 3x squared on the left, and on the right, we have 2 times 3x in the numerator, equal to 6x. And 1x times 3x is 3x squared, the common denominator that we want. Now that we've got that common denominator, we can combine the numerators together. And this is a subtraction problem, so we're going to do 1 minus 6x in the numerator. And those are not like terms because x has a variable and 1 is just a coefficient on its own. So we cannot put those terms together. We'll just leave them separate in our numerator. And that would be our final simplified answer. There are no more common factors that we can divide by in the numerator and denominator, even though we do see there is an x in the numerator and x squared in the denominator. Both terms in the numerator would need to have an x, and this coefficient 1 does not have any variables attached to it, so we cannot divide by x.